you can apply limit separately for f of x and you can apply limit separately for g of x. Indeterminate. Now 0 by 0 is mathematical indeterminate. Dear students, whenever we have product of two functions, you can apply limit for each function. Whatever is present inside the sign and denominator and this, all three should match and it should tend to 0, then answer is 1. You know, if you have product of two functions, you can apply limit separately for each function. Welcome to the session, dear students. Today we'll go ahead with problems of limits and derivatives. Find the derivative of sin x by first principles. See, by method of first principles, you need to find the derivative of sin x. So now, first to derive this, the basics. So let me just summarize the basics. So please remember the basics, then we can go ahead. So basic number 1, you should know sin c minus sin d. Should know what? Sin c minus sin d. Sin c minus sin d is what? 2 cos c plus d by 2 into sin c minus d by 2. Basic number 1. So you should know trigonometry transformation sin c minus sin d. What is sin c minus sin d? 2 times cos c plus d by 2 into cos c minus d by 2. First one. Second one, you should know method of first principles. You know method of first principles, f dash x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Third one, you should know sandwich theorem. What is sandwich theorem? Limit x tends to 0 sin x by x is 1. Most important. And fourth one, you should know algebra of limits. Algebra of limits is what? So limit x tends to a, f of x into g of x means you can apply limit separately for f of x and you can apply limit separately for g of x. Limit x tends to a f of x into limit x tends to a g of x. Like this you can apply. So these are the 4 formats you should know. What is the first one? You should know sin c minus sin d. What is sin c minus sin d? 2 cos c plus d by 2 into sin c minus d by 2. Then you should know derivative. F dash x is limit x h tends to 0 f of x plus h minus f of x by h. Third one, you should know limit x tends to 0 sin x by x is 1 and product of functions means you can apply limit separately for each function. Coming back to this. So these are the basics which you should remember. Now we'll start up with the derivation. Find the derivative of what? Sin x by method of what? First principles. So first let us assume let f of x is equal to sin x. The given function you assume it as f of x and f of x plus h. F of x plus h is what? Sin of change x to what? X plus h. And now by first principles, by method of first principles, by method of first principles, all of you know f dash x can be written as limit h tends to 0 f of x plus h minus f of x divided by h. So now I will substitute in this formula, that is f dash x is equals to limit h tends to 0 f of x plus h. F of x plus h means what? Sin of x plus h minus what we have? F of x. F of x means what? Sin x divided by h. So now further, in the place of h if you put 0, this will become x plus 0 is x. So it will become sin x minus sin x. You know sin x minus sin x is 0 and denominator also becomes 0. Suppose in the place of h if you put 0, it will become 0 by 0. So directly we cannot apply limit. Just I will show you what happens when you put 0. Suppose in the place of h if I put 0, sin of x plus 0 minus sin 0 by 0, sin x. In the place of h put 0. H tends to 0 means wherever h is there put what? 0. Wherever h is there put 0. So divided by 0. So numerator becomes sin x minus sin x divided by what? 0, that is 0 by 0. You know whenever you apply limit you should not get determinant. indeterminate. Now 0 by 0 is mathematical indeterminate. So you should not get mathematical indeterminate when you apply 0 by 0. So that's why we cannot do this. So directly we cannot apply limit. So if you apply limit, what happens? I should not require this part, whatever I am writing in bracket, just to make you understand that. Suppose in the place of h, if you put 0, it will become 0 by 0. Because it is giving you 0 by 0, I should simplify. How to simplify? So limit h tends to 0 you take, and numerator is sin c minus sin d. So use the formula sin c minus sin d. What is sin c minus sin d? I told you sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. So this can be written as 2 cos c plus d by 2. C means x plus h. C plus d by 2 into sin c minus d by 2. X plus h minus x by 2 divided by h. Further it will become limit h tends to 0, 2 cos x plus x is 2x plus h by 2 into, I can cancel x and x, so it will become sin h by 2 divided by h. So further you can split it into two functions. So limit h tends to 0, 2 cos 2x plus h by 2 into sin h by 2 divided by h. I am splitting it into two functions. So if you multiply, you will get same. 2 cos 2x plus h by 2 is separate, and sin h by 2 by h is separate. So this h m7, if you multiply, you will get same. Now if you have product of two functions, I told you, you can apply limit for each function. So now limit h tends to 0, first function. What is the first function? 2 cos 2x plus h by 2. 2 cos 2x plus h by 2 into limit h tends to 0, second function, sin h by 2 by h. Sin h by 2 by what? H. So we have two functions. This is first function, this is second function. If you have product of two functions, you can apply limit for each function by algebra of limits. That is, here I told you, if you have f of x into g of x, you can apply limit separately for f of x, and you can apply limit separately for what? G of x. Dear students, whenever we have product of two functions, you can apply limit for each function. So now this is product of two functions. 2 cos 2x plus h by 2, one function I will take, and remaining part into sin h by 2 by h, other part I will take. Now I will apply limit for first function and second function. For first function, directly in the place of h put 0. 2 cos, I am applying limit, in the place of h I am putting 0. So this h becomes 0 by what? 2. And here in the place of h, if you put 0, it will give 0 by 0. So reduce it into sin x by x form. So now h is tending to 0. Limit, what is tending to 0? H is tending to 0. Divide by 2 on both sides. H by 2 tends to 0 by 2. Sin, what we have? Sin h by 2 is there. Divided by, I have h. Now divide and multiply by 2. So instead of h, can I write h by 2 into 2? Because inside sin I have h by 2. Whatever is present inside sin, denominator should be same. So you can use sandwich theorem. That is, you can use sin x by x. You know, limit x tends to 0, sin x by x is 1, means this and this and this should be same. Inside sin, denominator, and this should be same. So that's why inside sin, when you see, we have h by 2. But here I have h. Make this h by 2, because inside sin I have h by 2. So internal term to the sin and denominator should match. But here it is h, but here it is h by 2. That's why for this h I am dividing and multiplying by 2. Now this 2 you take it out. Now 2 cos 2x plus 2, 2x by 2, 2x plus 0 is 2x, into this 2 I will take it out, it is in denominator, so 1 by 2, limit remaining part is what? H by 2 is there, this is h by 2, h by 2 tends to what? 0 by 2, 0 by anything is 0, sin what we have? H by 2 by what? H by 2. Now this 2 and 2 cancels, and I am left out with 2 cos x into 1 by 2 into, now this is in the form limit x tends to 0 sin x by x. So this term h by 2. Inside the sign I have h by 2. Denominator I have h by 2 and it is tending to 0. So by sandwich theorem the whole limit becomes what? 1. 1 by 2 into 1. Because it is in the form sin limit extends to 0 sin x by x form. By sandwich theorem it is 1. So now I can cancel 2 and 2. I am left out with what? Cos x. So cos x into 1 is cos x. So therefore what is the conclusion? Therefore f dash x is cos x. Dear students, if y is sin x, d by dx of y, dy by dx is cos x, or f dash x is cos x. So cos x means derivative of sin x is what? Cos x. We used method of first principle to derive this. Next we have cos x. They'll ask you to differentiate or define the derivative of what? Cos x by method of first principles. To derive this again, as usual, you should know basics. Basic number 1, first principle formula. What is the first principle formula? Limit h tends to 0, f of x plus h. This is, what is that? F dash x value. Derivative is limit h tends to 0, f of x plus h minus f of x by h. And second important thing you should know, cos c minus cos d. What is cos c minus cos d? Cos c minus cos d is minus 2 sin c plus d by 2 into sin c minus d by 2. Both will be sin terms only. Sin c plus d by 2 into sin c minus d by 2. And third thing, sandwich theorem, that is limit theta tends to 0 sin theta by theta is 1, or x tends to 0 sin x by x is 1. So these are the three basics you should know. And as usual, if you know the fourth one, that is limit x tends to a, if you have product of two functions f of x into g of x, then you can apply separately limit for first and separately limit for second. Limit x tends to a f of x separately into limit x tends to a g of x separately. So if you have product of two functions, you can apply limit for each function. So these are the four basics which helps you to derive. One very important thing here is cos c minus cos d. What is cos c minus cos d? Minus 2 sin c plus d by 2 into sin c minus d by 2. Both the terms are sin. And sandwich theorem, limit x tends to a, sin x by x is 1, or limit theta tends to 0, sin theta by theta is 1. What is the meaning? Meaning is whatever is present inside the sign and denominator and this, all three should match and it should tend to 0, then answer is 1. Cos x divided by 0 or 0 by 0. I told you whenever you apply limit, you should not get 0 by 0. So therefore, whenever you apply limit, you should not get what? 0 by 0. So this method, so just to make you understand, I wrote this is not required. So understood? Suppose directly if you apply limit, what is meant by direct application of limit? In the place of, in the place of h, if you put 0, you will get 0 by 0. So that's why you should not put 0. So what we'll do, we'll simplify. I'll write it as limit h tends to 0, cos c minus cos d. What is cos c minus cos d? Minus 2 sin c plus d by 2. C means this whole thing, x plus h, d means x, c plus d by 2 into sin c minus d by 2, x plus h minus x by 2 by h. Now simplify this further. So limit h tends to 0, minus 2 sin x plus x is 2x plus h by 2 into x and x cancels sin h by 2 divided by what? H. Now further split it, limit h tends to 0, write them as two functions, minus 2 sin of 2x plus h by 2 into the second function, I will take sin h by 2 by h. Now we have product of two functions, means I split this whole thing as into two functions. This is the first function into this. If you multiply, you will get the same. Because we can apply the formula, if you have product of two functions, then you can apply limit for each function. So now I will apply limit for each function. So it will become limit h tends to 0, first function. What is the first function? Minus 2 sin 2x plus h by 2 into limit h tends to 0 sine h by 2 by h. Now the first term you can apply limit directly. Now in the place of h put 0, so it will become minus 2 sine 2x plus 0 by 2 into, now if you observe inside sine we have h by 2, but here I have h, so make the denominator also h by 2. So what we do, limit h is tending to 0, so I will divide by 2 on both sides, h by 2 tends to 0 by 2, and sine I have h by 2, but denominator I have h, so I am dividing and multiplying by 2, so by 2 into 2. Now this 1 by 2 is constant, take it out, minus 2 sine, 2x plus 0 is 2x by 2 into this 1 by 2 is constant, take it out, then apply limit h by 2 tends to 0 by 2 is 0 sine h by 2 by h by 2. Now further minus 2 sine 2 cancels, you will have x 1 by 2 into, so now it is in the form, you can observe limit theta tends to 0 sin theta by theta, or limit x tends to 0 sin x by x form. So we can use theorem. By theorem it is 1. Now further 2 cancels, you are left out with minus sin x into 1, that is minus sin x. So therefore you got f dash x. What is f dash x? F dash x is minus sin x. So therefore if y is cos x, then its derivative means d by dx. D by dx means differentiation with respect to x, or derivative of y is what? Minus sin x. Or we also say d by dx of cos x is minus sin x. So this is by method of first principles. Then find the derivative tan x by first principles. So now we need to differentiate tan x by what? First principles. So how to do that? We will take y is equal to tan x, or f of x is equal to what? Tan x. So here first, as usual, so let me get you the basics required. What are the basics required? Basic number 1, you should know tan x can be written as sin x by cos x. In mathematics, tan can be written as sin by cos. That's the first thing. Second thing, compound angle. So you should know compound angle, sin of a minus b. What is sin of a minus b? Sin a cos b minus cos a sin b. So tan x, sin of a minus b, these two. And as usual, method of first principles formula. Apart from that, if you have product of two functions, you can apply limit separately for each function. So in maths, tan theta is what? Sin theta by cos theta. These are the two basics required. Now we'll go ahead with the problem. So in order to differentiate, so first we should assume the function. Let f of x is equal to given function. What is the given function? Tan x. Then you take f of x plus delta x, f of x plus delta x, or f of x plus h. H is increment in the function. That will be tan of x plus h. Now you write my method of first principles. By method of what? First principles. By method of first principles, f dash x is equal to limit h tends to 0 f of x plus h minus f of x divided by what? H. So for all the problems we are using method of first principles. What is method of first principles? F dash x is limit h tends to 0 f of x plus h minus f of x by h. Now f of x plus h, in the place of that put tan of x plus h, in the place of f of x put tan x. So now f dash x is equal to limit h tends to 0 f of x plus h means tan of x plus h minus f of x means tan x divided by h. So now again the problem is, in the place of h if you put 0, tan x plus 0 is tan x minus tan x is 0 by 0. It will become 0 by 0. Therefore, you cannot apply directly. So we have to simplify. So what we should do, numerator tan I can write it as sin by cos. So tan of x plus h I will write it as sin of x plus h by cos of x plus h. Similarly, tan x I will write it as sin x by cos x, whole thing divided by h. Now further we'll simplify this, that is limit h tends to 0. Take LCM for numerator. What is the LCM? Cos of x plus h into cos x, cross multiply. It will become sine of x plus h into cos x minus cos of x plus h into sin x. So in denominator we have h. That h I can write it here. I will write h 1 by h separately. So now 1 by h I will separate it, limit h tends to 0. Numerator, if you observe, it is in the form sin a cos b minus cos a sin b. Numerator is in the form sin a cos b minus cos a sin b. So sin a cos b minus cos a sin b, I told you sin a cos b minus cos a sin b can be written as sin of a minus b. This big term you can compress it as sin of a minus b. So now a means this whole term, a means x plus h. So here a means x plus h and b means x. A means x plus h and b means what? X. So now we'll compress. So sin of sin a cos b plus minus cos a sin b can be written as sin of a minus b, sin of x plus h minus x divided by remaining part. Remaining part is h into cos of x plus h into cos x. So now I can cancel plus x and minus x. So what is left out? I am left out with limit h tends to 0. Numerator is sin h divided by denominator is h into cos of x plus h into cos x. See here again in the place of h if you put 0, sin 0 is 0, h is 0, 0 into anything becomes 0, it will become 0 by 0. So what we should do? So we'll simplify this, we'll write it as limit h tends to 0. I'll write sin h by h separately and remaining part separately, 1 by cos of x plus h into cos x. So now we have product of two functions. You know very well, if you have product of two functions by algebra of limits, if you have limit of x tends to a f of x into g of x, you can apply limit for f of x separately into limit for g of x separately. So what I will do, limit h tends to 0 sin h by h into limit h tends to 0 1 by cos of x plus h into cos x. Now this is in the form of limit theta tends to 0 sin theta by theta, it is 1. Now in the place of h put 0, it will become 1 by cos of x plus 0 into cos 0. That will give you 1 ones are 1 divided by denominator. In the place of h we should put 0. Here cos x will be as it is. Here h is there, h I made it 0, cos x will be as it is. So I will be left out 1 by cos of x plus 0 is cos x into cos x. 1 by cos x into cos x is cos square x. 1 by cos square is what? Reciprocal of cos is secant. So instead of 1 by cos square, I will write secant square x. Therefore you got f dash x. What is f dash x? F dash x is secant square x. F dash x is what? Secant square x, or we say d by dx of tan x is secant square x. Derivative of tan x is secant square x. So sin x, cos x, tan x I have done. Cot x you can do by yourself. Similarly you can do secant x also. So now let me summarize. Dear students, so first you should be thorough with this formats. Differentiation with respect to x. Differentiation with respect to x means is d by dx, or we can also short form is derivative. So now we have done so many formats. Today 3 trigonometric functions I have done. So now first I will write standard functions. So standard functions, what are the standard functions? So d by dx of x power n. This is the first principles formula we derived yesterday. N into x power n minus 1. You should memorize this. And d by dx, again and again we cannot use first principles to derive. So now we will be applying them. In your 12th also they are important. D by dx of 1 by x minus 1 by x square. D by dx of root x 1 by 2 root x. All these things you can convert into first form and you can derive. Similarly, we also have the fourth one, d by dx of e power x. Derivative of e power x is e power x. Fifth one, d by dx of a power x. D by dx of a power x is a power x into log base ea. and sixth one d by dx of log x, d by dx of log base ex is 1 by x. So these are the 6 trigonometric functions: x per n, 1 by x, root x, e per x, a per x, log x. Then we have trigonometric functions. So trigonometric functions today we started. The first one d by dx of sine x. What is derivative of sine x? Cos x. And derivative of cos x we have done. What is derivative of cos x? Minus sin x. Similarly, derivative of tan x we have done. What is d by dx of tan x? D by dx of tan x is secant square x, and d by dx of cot x will be minus cosecant square x. Please make a note of all these things and become thorough so that I can start my class. So d by dx of secant x, derivative of secant x is secant x into tan x. And last but important, d by dx of cosecant x. D by dx of cosecant x is minus cosecant x into cot x. So 6 standard functions and 6 trigonometric functions I wrote. So please revise all this formula and become thorough. I'll see you in my next session with the derivatives. So thanks for attending. I'll see you in my next session. Thank you.